Okay, so we're showing precision and accuracy. Trying to hit the crossbar. Okay. See what happens. So in the end, neither me or Will were accurate, but we were precise with Will. Either over or under, and then I hit the two sides. Alright, so Newton's first law of motion says that every object continues in a state of rest or motion in a straight line at constant velocity unless it is compelled to change state by the net forces exerted upon it. Alright, so there aren't any forces acting on the ball right now, that's why it's not moving. But golf clubs are there so that the ball does move. 4!
We're doing Newton's second law. Force causes a change in motion, and when I hit a soccer ball, it will hit.
So Newton's third law says that whenever an object exerts a force on another object, the second object exerts an equal and opposite force on the first object. So when we throw the balls off the wall, the wall is going to exert an equal force on the wall, so it's going to come right back off. All right, you ready? 1, 2, 3. So the Newton's law of gravitation, everything pulls on everything else. Force of attraction depends on the mass of the two objects and the distance from each other. So even though you can't really see it right now, those two balls are having forces pulled on them because of gravity, and they're being pulled against each other and pulled towards the center of the earth. That's gravity. Alright, so using our calculations from the scale, I ended up being 978.2 newtons, and Will was only 1,046.81 newton. Using weight and is equal to mass and gravity, and that 1 kilogram was equal to 2.204 pounds, we were able to convert it, and there it is.
It's free fall. I'm going to drop the ball, and it's going to get to return the ball.
Alright, so we've mapped out what 50 feet is. We're going to calculate the acceleration of the car. When it goes that 50 feet, Will's got the timer. Are y'all ready?
The formula for acceleration is delta v divided by t, which is the change in velocity divided by time. The car accelerated to 25 miles per hour in 3.85 seconds. So what we have to do is convert the 25 miles per hour into meters per second. So we follow along this conversion chart here, and in the end we get 11.17 meters per second. And then we take that number and plug it into the equation that we started out with, and so we do 11.17 divided by 3.85 seconds, and we get 2.90 meters per second squared.